So we can now put these terms together to build up our Born-Haber cycle. So those are our enthalpy changes that we're going to use for our Born-Haber cycle. Now the first thing we can do is we can try and find a common endpoint. So let's find a product that appears in two of those equations. And you'll hopefully see that NaCl solid appears in both. And now NaCl solid will of course be the lowest energy product out of all of those. So when we put that on our energy level diagram, that's going to be at the bottom. And now we can, when we've got that at the bottom, we can now put in those two enthalpy cycles. So let's go for, first of all, my lattice enthalpy, which is going to be on the right hand side. And then we can also put my formation, which will be on the left hand side. And it's going to be the left hand side that we are going to now build up. So if we now look at our left hand side and the second line up, so we have gone for, we've now got sodium solid and a half Cl gas. We need to find an equation from the four of those above, which starts either with Na solid or half Cl2. And you can see I've got the first two going from the left hand side have that. So let's first go to sodium. So we're going to take sodium solid and we are going to atomize sodium. And the next thing, let's take our chlorine and do the same to chlorine. So we have now got gaseous, 1 mole of gaseous sodium atoms and a mole of gaseous chlorine atoms. So next thing I think we could do is we could ionize sodium. So we do the first ionization of sodium to give me Na plus gas plus an electron plus Cl minus. And you see we're almost there to lattice enthalpy to connect those two together. Lattice enthalpy, I only need to now produce Cl minus gas. So that's the last enthalpy change that we have to deal with. And that is the first electron affinity of chlorine. And that is going to be an exothermic value. So rather than carry on going up, we're actually going to bring our lattice enthalpy down in energy because the highest energy state out of all of these is going to be Na plus gas plus an electron plus Cl minus, and then we're going to go down to give me the due to the due to the electron affinity of chlorine. So let's put some letters on those to make it a little bit easier for now us to create a cycle. So let's have a look. Hopefully you can see that if I was to follow arrow A in that direction, arrow A is the same as following arrow B, C, D, E and F because they are all going in the same direction. So if you think of it this way, if you were following directions on a map and you were to follow, you started off at that Na solid plus a half Cl2 gas line, and you were to follow the red arrow, you would just go straight down and you'd end up at NaCl solid. Alternatively, you could follow the arrows marked B, C, D, E and F and follow a more circular route, but you would still end up at NaCl solid. So we can put that in an equation that A is going to equal B plus C plus D plus E plus F. But I want to find F, so that rearranges to give me the lattice enthalpy is equal to the enthalpy change of formation minus all the other values. Now we need to be a little bit careful when we do the maths here. So we're going to put those numbers in, and you can see that it's far better to keep all of those numbers in green, so the 107, 121, 496, and minus 364 in a bracket and work that out before trying to put that with a minus 411. That becomes minus 411 minus 360, which gives me a lattice enthalpy of minus 771 kilojoules per mole, which I'm sure you can see is a very large exothermic value.